Welcome back to the second part of the rectilinear propagation of light. Main subtopic is ray of light and beam of light. A ray is a narrow stream of light of negligible thickness, while beam is a collection of rays of light. Therefore, types of beams. We have three types of beams, where we have parallel beam, convergent beam, and divergent beam. We start with parallel beam, a beam in which rays are parallel to each other. Convergent beam, a ray in which the rays converge at a point. So is being demonstrated when we are using the hand lens. It concentrates all the rays to one point. Number 3 is the divergent beam. This is a type of beam in which the rays spread out from a point. This one is demonstrated when we are using a hand torch, therefore enable us to see a large area. Therefore, these are some of evidences of rectilinear propagation that can show light travel in a straight line. One is the formation of shadows by an opaque object. Number 2 is eclipse. Number 3, image formation by a pinhole camera. Starting with evidence number 1, formation of shadows by an opaque object. Therefore, a shadow, what is a shadow in simple terms? A shadow is formed when light is blocked by an opaque object. The types of shadows formed depend on the three factors. Factor number 1, the size of the source of light. Number 2, the size of the opaque object. Number 3 is the distance between the source and the object. Those are the three factors that determine the formation of the shadows. Therefore, a shadow formation by a point source. What do we need? A small source of light. Number 2, the experimental demonstration can be carried out to show the image formation by a point source. The apparatus required for this demonstration, we have a pencil. Number 2, we need a bulb in a tin. Number 3, we need a screen where this shadow is going to be formed. Procedure. What are some of the procedures that are we supposed to follow in order to demonstrate? Number 1, place a source of light inside a tin which has a small pinhole as shown below. The diagram will be on the next page. Number 2, place an object on the path of light ray. Number 3, place the screen behind the object. Therefore, our demonstration is here. This is a source of light. The next, we have a hole, a cardboard having a hole. Number 3, we have our pencil. The other one we have is the screen. When this rays of light passes through the hole, it's going to encounter the pencil. Therefore, our shadow is going to be formed at this point. The shadow formed is uniformly dark, as you can see on the shadow on the screen. This shadow is known as umbra. The umbra is part that is completely in darkness and receives no light. A point source forms umbra. Therefore, this is a very simple demonstration to show the formation of the shadow given the light, given the object, and given the screen and a point source. Our next is the shadow formed by an extended source of light. What will be the effect of this extended source of light? If we have an extended source of light, we have here a cardboard allowing a source of light to pass through. We have the screen. The screen is going to act as to spread out the light that comes from the other point to extend it. what is going to happen? An extended source of light is large enough for rays to be seen come from many points. The shadow is larger and has a central dark region. The central dark region, we have two parts here. We have the dark and the other one is partially dark. So the two regions is one, the darker is called umbra and the other partial is called penumbra. Therefore, what are some of the applications of these extended light source? One of the application, we normally apply it in our real life situation. Number one, we have the lamp shades that we use in most of our homes. Most so when you visit to supermarkets, they normally use this, what we call the lamp shades, used at home to provide a more pleasant kind of lighting. Number two is what we call the fluorescent tubes that we normally use in our schools and in our homes. It's being surrounded by a fluorescent diffuse to scatter the light and reduce the sharpness. Therefore, these are some of the application of the extended beam of light in our real